All right, well, it looks like we're at the top of the hour. This is Lou Berger. We also have Pavan Biram with us. We're the chairs of TEAS. Thank you so much for joining us online at IETF 111. On this slide, you'll see a pointer to where we're taking minutes. That also has been sent into chat. We would ask that you come join us and help us capture minutes, whether you add a comment that someone else says or make sure that your comment is appropriately captured. All of that helps us accurately document what goes on today. I do want to point out that there is a change to this slide. Notably, Matt Hartley, who has served as secretary for many years, has said that his obligations preclude him continuing, and we really appreciate the help he has given us. The secretary is often a behind-the-scene type of role, but it's been very important to us. We are working on bringing on a new secretary. That's not finalized, so we don't have it up on this slide. Hopefully, everyone is seeing slide 2, which is the IETF Note Well. Today's the first day of the IETF 111, so some may not be familiar with the practices that we follow in terms of how we conduct ourselves, as well as how our information that is contributed to the IETF by through your participation becomes part of our permanent record. If you are unfamiliar with the Note Well, feel free to pull our slides down, which there's links in the Code EMD. And there's also the main Note Well page right at the bottom. That's really the right place to go to read about this. You're here on Meet Echo, so that means you figured out the first part. Thank you so much for joining. That's great. Note taking we've talked about is through collective note taking. We used to use Etherpad. Now we use a tool called Code EMD. If you click on the both screen, you can enter. If you get onto a screen that looks like you can't enter information, go to the top, and you can also hit Control-Alt-B. We really appreciate anything you can do to help take those notes. All the material you're seeing here is online and available, you know, we make it available so that for your reference. We have a super packed agenda. The being online hasn't reduced the demand. We apologize for having the agenda be so tight, but this is what it is. We do point out, and it's in the slides, that we can have interim meetings that are driven by the desire for participants to have a longer period to interact. We really encourage both informal meetings and formal interims, and all it takes is contact us. I believe we're going to suggest at least one possible interim as we go on, but let's see how the discussion goes. In addition to interim meetings and also informal online meetings, we do have the mail list. We encourage you to use that list. It's actually where all of our final discussions take place and how we judge consensus. It's based on those discussions on the list. It's great to have informal meetings among authors, but decisions made informally among authors are not decisions of the working group. Our process requires that the decisions be discussed on the list and the consensus be gauged on the list. Just a reminder, we do have a formal IPR disclosure process within the working group. We did add a step a little while back about when you add authors, we're going to ask for IPR statements, and you'll see that going on with one of the documents who had a recent edition of authors. So we have one new RFC. Thank you to all who contributed to making that happen. It's always good to see those happen. And of course, that's the reason why we're here. Yes, we love discussions, and we once loved traveling to the meetings. Hopefully we'll get back there sometime soon. But the real purpose here is to produce RFCs, so it's always good to see that happen. And thank you again to the authors and others who contributed within the working group. We have one document whose publication has been requested. That's with our AD, John. I assume John Scudder is here. Hopefully he's here noting that. If not, we certainly will mention that to him. Actually, I see him listed. So that's with John. We have John, do you? No, I thought he jumped into queue, but John, if you want to say anything, feel free to jump in anytime you want. You are the one we work for. Well, at least you manage the process. Go ahead, John.
No, you work for the human race or the IETF or something like that.
Yeah, for the betterment of mankind.
I'm just here to help. But yeah, I just stuck in the chat that yes, I know that I have that in my queue, and I will be working to flush my somewhat backed up queue over the next few weeks.
Yeah, understanding the transition is always painful. And thank you for doing that. We have one document that has been recently, relatively recently adopted, and it's on the agenda. Actually, the next one's on the agenda, I'm sorry. We have the merged document, and we'll be talking about that shortly. I think Adrian is on the agenda for that. We have one incoming liaison that was addressed to multiple working groups. We are at the bottom of the list of that, and we are looking to CCAMP to take the lead on the response. They have historically been the lead on the response to IQT. This is basically just saying, tell us about anything that you think is relevant to us. And so usually that the process is run in CCAMP. Often it's reviewed in T's if there's something specific, but sometimes it's not. With that, I think I am done with the intro, and we're going to move on to the next topic, which is just an update on the consolidated update on working group drafts. Pavan, do you want to take it?
Yes, I'll start sharing. Okay. Hello, everyone. I'm Pavan Biram, your other co-chair. Next on the agenda is the working group document status. We have 21 working group documents. 3 of those colored in blue here are on the agenda today. We have one document, the one in black. That's the signaling extensions draft for SMP, for which we put in a publication request last month. It's with our AD. So that leaves us with 17 documents. The status for each of those 17 is covered in this deck. Given the packed agenda, I will not be walking through each and every one of those. I will, however, double click on a select few and dwell on them a little bit. For the rest of them, you can at your own pace go through the slides and the reports that were sent out to the list. And if there are any questions or concerns, please do reach out to the authors on the list. So let me jump to slide 4. This is the ACT and VN Yang document. There haven't been any updates to this since the last meeting, but there was a discussion point from the last meeting that we haven't closed on. This is with regards to which topology model and which tunnel / path model are to be referenced in the VN Yang model when the underlay paths are placed using segment routing. For the topology, the suggestion was to reference the SRT topology model that's being discussed in this working group. We haven't closed on what to use for the tunnel or the path construct. We would like to request the authors to initiate a thread on this on the list and see if we can get some closure on this. And we will have a similar comment for the SRT topology data model as well. But it would be good to get the discussion going and reach some consensus on what the next step needs to be. Let me jump to slide 8. This is the PCCC use cases document. The chairs have decided to take this to the last call. The authors mentioned last time that there were a few empty sections that they would like to fill in before it can progress to the next step. So authors, please do take care of this. I do see Drew has already initiated a thread on this. We would like to see this get wrapped up before the next meeting. Next, let's go to slide 10. This is the SF-aware topology model. The authors have said that they are almost done with this. We don't seem to have done a young doctor's review for this yet. We will go ahead and initiate that for this document. Let's jump to slide 17. This is the SRT topology Yang model. This is also almost done. Since this would potentially be the first document from our working group with the term SRT that would be progressing to the publication stage, the ask from the chairs is to have this document define what SRT actually means and also discuss the relationship with SR policies in general. This can be discussed and debated further on the list. If the authors have any questions regarding this ask, please do reach out to the chairs. We would be happy to clarify. Any questions or comments before I jump to one other draft? Okay. Let's jump to slide 18. This is the base T Young document. The authors believe that this is now ready for working group last call. A lot of work has been done to get the document to the stage. A lot of hours have been put in, thanks to everyone involved in this activity. The plan for now is to progress this document and 3 other documents, the RSVP Young document, the RSVP Young document, and the TMPLS Young document to the last call in the next few weeks. The exact order in which this will be done hasn't been decided yet, whether the T and RSVP models go first, followed by the other 2, or if all of them go together over an extended last call period. Those details need to be ironed out, but please do review these 4 documents in anticipation of the last call. Those are the items that we wanted to cover as part of this deck. If there are any questions either on these items or any other working group document, now would be a good time. Okay, I don't see anybody in the queue. I think we can jump to the next presentation. I think that would be Dan.
Hi guys, thanks. So this is a very short presentation on a piece of work. It's essentially an applicability statement for using ACTN for packet over or packet optical integration. Next slide, please. So essentially, we wanted to document how we can use some of the various TEAS models and the ACTN architecture, along with a couple of key use cases for packet optical integration. So we're very good at developing these technology Yang models, but often we find that there are things missing with the operational security sort of manageability considerations, and indeed the models themselves may have particular gaps. So this is a cookbook for using the different pieces of TEAS technology, as well as sort of some of the Yang models developed within TEAS, the generic sort of Yang models, and then the technology specific augmentations that we might sort of use from CC and other working groups, and then combining those all together and seeing if the sort of implementation, procedural steps, data models, and sort of identified manageability, sort of operational and security aspects have been sort of carefully considered. So the topology that we have there is relatively straightforward. We talk about in the document how we start up, essentially bootstrap the network, link discovery, both in the underlay and the overlay, or the server and the client layer. We talk about the different ways of populating the databases with the PNCs and the MDSC, and then how we actually set up services. Next slide, please. So there are a number of sort of open issues currently with the document itself, and those are mentioned on the GitHub. We do try to reflect sort of key discussion points to the mailing list and occasionally during the working group sessions as well, because we don't always present this particular document. So we don't want to fall into the trap that kind of Lou highlighted earlier, which is to sort of reach conclusions, make decisions without following IETF sort of working group process, especially consensus. It's worth pointing out, of course, that another reason for writing an applicability sort of document / statement is to identify gaps. And what's not on this slide actually is the fact that we do sort of have a number of gaps that were identified when we were sort of working on this document. It will be things like the management of the network inventory, sort of how we populate that and who is responsible for it, both for packet and optical. And also there was a gap for communication between the MDSC and the PNC to set up the SRT path as well. So these are sort of SRT augmentations for the TE tunnel model. And then finally, I think we had some optical augmentations for the path computation RPC. So, what do we need help with right now? It's making sure that the use case we've got and the way we approach the deployment, generally from the operator's perspective, is suitable, is a good case study. So we want reviews of the document. There are some security considerations that we're dealing with at the moment, especially around some of the discovery and negotiation between the various nodes, both in the optical and the packet layer, so sort of LLDP snooping. There are some sort of protection and restoration aspects as well, using local protection with things like TI-LFA needs to be documented in the draft as well. So we expect to have a fairly stable version of the document that we will submit shortly after this IETF. And now we would like the working group to, those who are interested, to review that and comment. Thank you.
Any questions for Dan?
That's great. Thank you. Adrian.
Okay. Well, we'll see how this works. I've never driven remotely before. So we have a draft we've been working on for a little while, which is a revisiting of RFC 3272, which is just over 20 years old now. So we have been working initially with the design team, and then once adopted, with me as lead editor and people making suggestions and providing text. And the joy is, how do you page down? Right. So 2 revisions since the last IETF, so in the last 4 months. Revision 11 added a small section on intent-based networks and also on multi-layer TE. Thanks to Lou for suggesting that we needed that. And then, because the draft seemed to be approaching stability, I added in the change log from RFC 3272. The change log, or at least a detailed description of what's changed, is usually seen by the IESG as a requirement when we BIS an RFC, so that readers can work out what changed and why it changed. And then revision 12, Med did an excellent and detailed review of revision 11, and most of that got caught in the update for revision 12. Some reordering of sections, bringing the taxonomy forward, so it's easier to parse the document, and a good number of small clarifications and nits, all of which have improved the document. I guess somebody's paging down for me since it doesn't do it.
I did that.
No, thank you. Tooling was very odd here. So what's left to do is closing in on Med's final comments. And the author has carefully left a blank here. There was an item that needed final clarification from Med, and then Gian has also done a detailed review that came in sort of overlapping with me posting -12, which is fine. Some suggestions for additions for multicast and different types of protection and ECMP. Also then proposing to add an explanation of how SRv6 uses SRTE as at least a variant on the full traffic engineering concept. Some editorial points and 2 points of wider impact. Next slide, please. So Gian made a suggestion that the current title, which is Overview and Principles of Internet Traffic Engineering, should actually be expanded to address traffic engineering more generally. The same technologies, but inclusive of public internet and close or restricted MPLS domain, private traffic engineering, etc. With a potential change there in the abstract to reflect that expansion. This is something really that I guess the working group has to decide on. There are two issues there. One is it's a change of direction from what 3272 originally had, because that very clearly said internet. And the other issue is it's potentially a large lump of work to go through everything and check the applicability to different scopes of network. I think I leave that as a matter of debate and discussion. And then next slide.
Do you want to take questions now or at the end? Oh.
Well, since both are the same, we can do either of them.
So we have a moment or two if anyone would like to come to the floor. I know I have a comment as chair, but we should give an opportunity to the working group to comment first. Seeing everyone is rushing to the mic, I'll make, oh, Tony.
If this is meant to be a BIS draft, shouldn't the scope remain the same?
Well, that is certainly my question, but of course, if the working group decides that what it wants is a wider scope RFC, then it stops being a BIS and it becomes I suppose, a replacement with additions.
Other comments? Okay, so I think I have a comment and a question. One comment is I think we should be careful to not go beyond the scope of the IETF. I can read this to mean to cover techniques used in proprietary networks, because those are private domains that may have public customers, and clearly that is beyond the scope of the IETF. So if we wanted to say IETF or internet technologies, I think that would be within the scope of the IETF, and that was comment. The question really goes to the same point Tony was making, is what is not covered if we limit ourselves to IETF technologies?
So I didn't read Guillen's comment as saying move the scope beyond IETF technologies. I read it as a discussion of what the internet was and whether IETF technologies are applied in other environments.
So for me personally, I'd like to understand what additions we're talking about adding before we, to really address the point of, are we expanding the scope, or are we just clarifying what TE means in the internet today? And the usage has evolved over 20 years. And without specific examples, I'm not sure I can judge that question, but I think it's the key one. How much are we changing the scope?
I mean, you say it's potentially a large lump of work, and at least it's not clear to me what is that large lump. If we limit ourselves to TE as catered to by IETF technologies, I think most of it is already covered in this document. Yeah, it would be good to understand what that delta is and then make a call.
Sure. Okay. That certainly gives me an action to discuss on the list with Guillen.
Okay. You are the next presenter as well. Do you want to continue driving the slides?
Well, oh, you've just had Dan show up in the queue. I'm happy trying to present or whatever. It just wasn't working before.
Yeah,
Dan, go ahead.
So, coming late for the comment, Adrian, for your question. But for me, traffic engineering has to be, I don't know if it's the real debate, but it's something that the operators make money off with private network with customers. I don't see, I don't know, and then maybe the internet traffic engineering is just because it's IETF, and that's just something we carried over time, but has nothing to do with doing traffic engineering directly over the bigger internet, is it? Is it where you're coming from, and you're trying to have a little differentiator in between?
So I think that the meaning of the word internet morphs pretty much continuously through time, and you could read internet traffic engineering as being traffic engineering within the internet or traffic engineering of the whole of the internet. I don't think the latter is what's intended. So we should be able to work on some scoping language here that we can all agree on.
Okay, yeah.
All right, on to this presentation then. So this is the network slices work that's ongoing that the chairs so graciously asked me to edit. So what this draft is a merger of two documents that had already been adopted by TEES and were worked on by the design team pretty diligently, quite a lot of hard work and conference calls they put in to make those drafts. The intention is that it's a home for terms and concepts related to IETF network slices. So note particularly that we're not talking about network slicing in general, but we're talking about slicing of networks that use IETF technologies. So these are not what the 3GPP would call end-to-end network slices. And we're not interested in slicing networks that use other technologies. Additionally, it's not a place to document solutions. It's supposed to put the structure in place for people to go away and talk about the topic and develop solutions. And I still can't page down, Pavan.
Okay.
Thank you. So it feels like this has been going on for a long time, but actually we only started work merging after the last IETF meeting. And on April the 13th, I announced a top-level plan, which is here, keeping all the authors, making a simple merge to start with, and then starting to cut into the text, and after that, opening the space for discussion, with the intention that other people suggest text and ideas, but failing that, I supply text and ask for agreement. So we've had 4 versions so far. Next slide. 0.0 immediately after the status, the plan rather, was just a simple inclusion of the text from the 2 documents. I didn't delete anything. I just put all the text in and tried to move it between the sections appropriately. Didn't make any attempt to harmonize the text either. And then in the 0.1, I rationalized the structure, made some stylistic edits and formatting, but still didn't make substantive change to the text. Next slide. The 0.2, I really then pulled the text together quite a lot to remove duplication and started work on terms and consistency. The big ones there were that I picked the term customer, having had a bit of a debate on the list about customer, consumer, and client, and it was clear that we needed one term to cover this. Customer seemed to be preferred amongst the 3, and since making the change, nobody has actually successfully taken a hit out on me, so I think we're okay with customer. We also introduced the concept of a service level expectation. Previously, the text had unquantifiable SLOs. These were objectives that might be set for a slice, but where the customer couldn't actually be expected to measure on whether or not that SLO was being met. So rather than having unquantifiable and quantifiable objectives, we split this into SLOs being quantifiable and service level expectations covering things that you might request that the operator does for you, but then you've got no definitive way of measuring. And these include security provided in the network, geographic routing restrictions, limits on the occupancy of network resources, and isolation. So along with that came quite a long discussion on revising the text about isolation to make it clear what the customer could expect and might be wanting, and that it was an expectation, not an objective. And then there's in that version as well were some changes for network for realization, substantially cutting down the text, in fact, but showing that there were some tools in the toolkit already, sort of architectural tools that could be used. And then version 3, fairly small changes, some additional text to clarify the meaning of customer and provider, removal of definition or discussion of SNMP, and some editorials. Next slide. So where are we going? Sadly, I've been a bit busy in the last 2 months, so nothing much has happened, but we have 3 big topics. So let's do the next slide and we can talk about them. Network slice as a service, or network slice service. The issues here are really, how does a customer request a network slice? What are the actions and the information that's passed in both directions? And how is traffic directed to the slice? My belief is this should not be a data model in this document. We already have places to do that. I don't think it should even be an information model, but it's clearly part of the definition of a network slice. And John suggested some text on this some time back. So my next action with this one is to dig that text out, polish it, put it on the list for review. Next slide. The second point that's coming up is discussion about service endpoints. So it's slightly linked to the previous point. But this is about defining where in the network are these points of attachment between the customer and the provider. And again, John, who's been diligent here, initiated a discussion on this. And there was quite a lot of backwards and forwards and ASCII art. And it felt like we reached a kind of consensus. So again, my task is to dig out this old email thread, convert it into proposed text and put it on the list for discussion. And next slide. So the third upcoming point is a discussion of how we actually realize network slice services. So how is it requested? How are the resources assigned? How is the network operated to achieve this? And there are a couple of drafts out there that approach this question from different directions. There's the enhanced VPN work and some drafts, the draft best bar family from Pavan and Tarek. So I've been having some private discussions with those authors to try to get a bit of convergence on function and terminology. And we seem to be getting there on function, a little way to go on terminology. I want to try to get something that they won't fight about too much and then take it to the list to get wider discussion and approval. So at the moment, I'm putting together a sort of workflow diagram and some text and trying not to overcomplicate what this process is. And then we can discuss that on the list. Next slide.
That's it.
Yeah, that's good, isn't it? So we've got a minute and a half.
Questions? Comments?
That if we have trouble resolving on the list, that we could schedule an interim.
Yes, certainly. And if anything gets really meaty on the list, we should definitely look at an interim. So far, it hasn't been necessary, but I think these 3 questions could push us that way.
Kiriti?
I have a couple of questions. Sorry, I was trying to multiplex between this and CoinRG, so I might have missed something that you've already said. But in terms of the service endpoints, and I know that you had a discussion about the customer or the client or whatever you want to call it, but when we talk about network slicing or transport slicing, the endpoint could be the 5G network or could be an end customer. So are you thinking that either of them, whoever it is, would have the same actions when it comes to requesting a slice and requesting parameters for a slice?
So the end customer of a slice, are you talking in a 3GPP end-to-end network slice concept?
What I'm thinking is that the transport slice that we're focusing on in the IETF could have as a end customer 3GPP endpoint or a 3GPP slice, slice, or it could be an actual customer. So if I'm Verizon, I'm running a network, and someone wants to come to me and get a service, I could say, hey, I can give you a slice. And so it is an actual end customer, the same way as as would be today, or it could be a 3GPP slice. And so the question, so I think it could be both. The question was more about how I request a slice and what parameters I give. The slide where you said I don't want to talk about data models and information models, but there is the process of requesting a slice. Would it be the same no matter who the customer is?
Well, no, because some might be paper and some might be Yang models and some might be procedure calls. But I think that at a somewhat meta level, yes, it is the same procedure for requesting a slice, and that's what this slide that's currently projected is trying to look at.
Yes. Yeah, this is the slide I was talking about. But I mean, I understand that there's different ways of doing this, but the differences are. You're saying that the differences don't matter who the customer is. The differences matter what kind of slice you want.
I'm sorry to cut a good discussion short, but unfortunately, the way we're set up, we really are tight on time. Can you take the good discussion to the list? And
sure. Yeah.
Also, I think we have following presentations might help answer that question.
Good. Hi again. This is Dan again. Now talking about the applicability of ACTN to network slicing. In fact, this is a piece of work that we started. Oh, next slide, please. This is a piece of work that we started approximately 3 years ago when we were sort of looking at requirements and starting the discussion on IETF network slicing. So it's not a working group document, it's an individual document. Our intention really was to understand if and how we would use ACTN to kind of deploy and operate network slices. So there's a number of use cases that we identified, a variety of network slices, things like sort of VPL, VPN, and sort of rather than sort of point-to-point or multi-point type topologies, also providing a network, a virtual network to a type of customer that they can then sort of slice or segment further. We obviously predated some of the more recent work, including what Adrian's just kind of talked about, but we were mindful that there are sort of key T's documents that we needed to sync up with. So we've essentially worked with the enhanced VPN folks and also the network slices folks, and we will continue to work with some of the other sort of individual drafts that are also being discussed. Wherever possible, using terminology that's been agreed and defined by those T's documents, and then sort of providing relevant references as well. So we kind of focus, as mentioned, on ACTN to deliver sort of slice-based services. We talk about the resource management, the models, the protocol interfaces, resource isolation. It's really sort of, again, another cookbook. Next slide, please. So what to do with this individual document? Well, it's been helpful in the context of as the network, the IETF network slice discussions progressed and matured, looking at how we apply the ACTN architecture and those sort of key interfaces between the CNC and the MDSC and the MDSC and the PNCs, so the CMI and MPI. And also what technology models are available, what terminology. I think it's been really kind of helpful. The key question for us now as authors is, have we done enough just to demonstrate that ACTN is obviously applicable to network slicing, and these are the components that you can use, and deploying them for particular services. These are the examples that we've provided. Where there were or continue to be identified potential gaps around sort of operational security, how you might troubleshoot, so what telemetry models or more traditional management techniques might you use. That's kind of another area of investigation that we're looking at. What we potentially have done as well with this document is remove the necessary discussion from other documents. For instance, that TEAS IETF network slices document that Adrian just talked about, we can essentially say that we've saved that document multiple pages of text by having this document. And I think the same for the enhanced VPN document as well. So we wanted to ask the working group and the chairs really what they might like us to do with this document. So those are the three options we've got at the bottom of the slide.
Anybody wants to quickly chime in?
So no questions then. So option one is we essentially take the useful content from this particular ID and move it sort of into some of the working group documents. Option two is to look to ask the working group if they want to support this work, and then sort of open it up to additional discussion and maybe direction. And option three is just not do anything at all with it.
Adrian?
Yeah, I'm really wary about the idea of taking the content of this document and moving it into the network slices document, because I forget what it is, Dan, but the page count on this document is not small, and even cutting out any duplication, I think that would seriously unbalance what's in the network slices document.
So we do have one comment in Jabber from Joel that option 2 seems like a good path. I'll also point out that in the past, when we've had this type of discussion, we've said it's good to adopt the document and then figure out how many documents we have. If we continue mature the text and making sure that it covers the topic appropriately, even at the last minute, we can rearrange documents. So from a process standpoint, generally, we have followed option 2. Trying to wrap things up, you saw that we're over on time. I'd like to just see if we have any objections. Anyone want to come to the mic for a last objection? And if you are not interested in speaking at the mic, please send it to the list. But option 2 seems like a good plan. Thank you. Next up.
Tarek?
Hello?
Yeah,
can anyone? Okay, great. Hi, everyone. This is Tarek, and I'm providing this update on behalf of all the co-authors. So this document is a solution document for realizing network slices in IP and BLS networks. We have presented the solution multiple times in previous sessions. I'm going to restrict my update here to the changes from the last revision and any interactions that we will report on. Next slide, please. I'll talk about the updates in this slide. In terms of co-authors, we have one new co-author who joined in the latest revision, Reza from Nokia. We have received positive review and feedback from several working group participants. I'll mention Francois Clad from Cisco provided positive feedback. We are working with Zafar offline, and we have agreed to incorporate any material that is missing in our best bar document that is in the building blocks draft -LE that he's driving, and eventually Zafar has accepted to join our draft. We have had meetings with the editor of IETF network slices, these network slices, and we will report in more details on this in the subsequent slide. We've also met with the authors of Enhanced VPN document, and we have an update on the agreement on this one. And lastly, I'll be updating, in addition to the TEAS-NS packet draft, I'll be giving a quick update on the slice policy Yang data model. Next slide, please. So I mentioned that we've met with the editor of IETF's network slices document, namely Adrian. He did mention us in his update. We were engaged in the production of a common set of procedures for the workflow of different components to realize an IETF network slice service. As he mentioned, there is a suggested text that is going to be floating around, and the working group is welcome to comment on it. From our side, next step is to reference this text if it gets into the document, TEAS IETF network slices, or we will directly incorporate it in our document and progress further. So our ideal objective is to have it in the network slices document. Next slide, please. We have had meetings with Enhanced VPN document authors, authors of the Enhanced VPN document. We had discussions on the aligning of the alignment of the goals for virtual transport network, or VTN, and slice aggregates that we are proposing. We have identified common goals and that we need when we're realizing IETF network slices. We came to an agreement that a new term for the aggregate construct might be needed, and we are proposing, both us as the authors of Best Bar document as well as the Enhanced VPN authors are proposing that this new term be defined in the network slices draft. So we might require Adrian as well as others' help to get this new generic term. So both authors of both drafts will reference the new term in their solution document and when they're realizing IETF network slices. In terms of protocol extensions or Yang data model, we will use the new term, and we will reference the common set of extensions. We have no intention to produce different protocol extensions for each, so that will only be one set of protocol extensions, and will be referenced in the specific document. Next slide, please. In terms of the Yang data model for the slice policy that we're proposing, we've added two updates. One is a new data node for the LSP forwarding label inferred slice selector. And we have introduced, we already had the topology filters in the Yang data model, but there is a wider applicability for those topology filters. as was identified in PCE working group as well. So we have moved this topology filter modeling into a separate document. I have the draft there, pointer to it. And we've updated the data model to reference the specific external module and new module. Next slide, please. In terms of next steps, so we already requested working group adoption. We think it is our best bar document is in a stable state to progress to being adopted. So we value the chair's feedback on that, and as always, we welcome further review and feedback from the working group. Thank you.
Before opening the floor, I'd like to comment that you've mentioned quite a few things where there's been private discussion and decisions made, and I don't believe that those have been reflected on the list. I'd like to see all of those reflected on the list before we open the topic of working group adoption. And I've also privately said that I think that the document could use a little bit more clarification on scope in the text, not in explanation, but in the text itself. Clarification of scope. That's it.
Okay, thank you, Lou. Yeah, agreed. We will make those agreements public on the mailing list. They did happen at the last minute, so some of them did happen last minute. And
yeah, there's nothing, to be clear, there's nothing wrong with private discussion. It's the way we get things done. It's just we have to bring it to the list and expose those discussions and those private agreements and make sure there's consensus on them. It's good to make progress. So thank you for making the progress. I see we have gentlemen in the queue and probably time for one quick question.
Robin, go ahead.
First, because now this several drafts, the overlap and should be coordinated. So I think that's for the draft is better to coordinate with other draft and to refine the text to solve the possible overlap. Second point is in order to accelerate the network slicing work, I suggest that we have this more inter-meeting to solve these overlap issues and aligned with each other. Okay.
Sure. Thank you. Thank you, Robin.
G?
Yeah.
Hello?
Yeah, good. Go ahead, G. We can hear you.
Okay. Hello, everyone. I will give a presentation of the update, the scalability considerations for the enhanced VPN or VPN Plus on behalf of the co-authors. Okay, next page, please. Okay, first a little recap of the VPN Plus and VPN terms. The VPN Plus framework is described in the enhanced VPN document, which described a layered architecture and the candidate technologies to provide the VPN Plus services. And as we know, one of the typical use cases of the VPN Plus service is for network slicing. And the VPN is defined as a virtual underlay network with a customized topology and a set of dedicated or shared network resources, so that we can provide the VPN Plus service by integrating the VPN overlays with the VPNs. And as we develop the VPN Plus solutions in the framework, we realize that the scalability becomes an important factor for the widely deployment of these technologies for the network scenarios like network slicing. So in this document, we provide the scalability considerations of the VPN layer, which are including the scalability analysis of the control plane and the data plane. And we also propose several scalability optimization mechanisms in this document. Okay, next page. Here we summarize some of the scalability optimization approaches we described in this document. For the control plane optimization, we highlight several possible approaches. The first one is we can reduce the number of the control protocol instances or the sessions for the VTN information distribution. So the suggestion is to use a shared control protocol instance or the shared session for multiple VTNs. And so we don't need to have a per VTN IGP instance or per VTN IGP adjacency. All this can be shared among multiple VTNs. In this case, we will need an identifier in the control messages to distinguish the informations of different VTNs. Then the second approach is we can decouple the advertisement and the processing of different types of VTN attributes, such as the topology attributes and the resource attributes can be advertised and processed separately. So this can give us the benefit of sharing topology and SPF computation among multiple VTNs, as shown in the figure on the right side. We can have, if we have multiple VTNs which have the same topology, they can associated with the same topology, and the SPF computation can also be shared. So we can reduce the overhead in the control plane. We can also reduce overhead of the in the advertisement for duplicated attributes. The third approach is we propose to have a hybrid control mode, which is to make use of both the centralized controller and also the distributed control plane to divide up the computation load so that we can improve the scalability of the whole system. Okay, next page. And for the data plane scalability, we proposed the approach to introduce a dedicated data plane identifier in the packet so that it can be used to identify the set of resources allocated for the VTN processing. So with this approach, we will decouple the VTN resource identifier from the topology-specific IDs in packet forwarding, as shown in the figure on the right side. We can have a separate IDs in the packet header, one to identify the topology or the path, and another one is to identify the VTN specific resource. So in the IPv6 data plane, this can be achieved by using the destination IP address for the topology or path determination. Then we can introduce a dedicated VTN resource ID to identify the set of resources used for the packet processing. With the MPLS data plane, the MPLS forwarding labels can be used to determine the topology and path, where we can introduce either a dedicated label or an extension MPLS header to identify the set of resources for the per VTN processing. Okay, next page. Here are some further considerations about the scalability, which we maybe for further discussions in both in the document and also in the working group. The first one is we need to consider what type of VTN information needs to be advertised in the distributed control plane, because there are some limitations in advertising large amount of per VTN information. For example, some kind of information can be centrally provisioned by the controller so that we can reduce the overhead in the distributed control plane. The second one is about the flash algo or multiple topology for the topology description. We know that flash algo supports up to 128 different logical topologies, while with ISS and multi-topology, it can support up to 4K topologies. So depends on the required number of topologies, we may need to consider which approach will be more applicable for the high scalability solution. And this draft list here defines the approach to use associated VTN with either topology or flash algo. The third one is about whether we can consider to use BGP to improve the control plane scalability. Okay, next page.
You are out of time. Can you start wrapping up?
Okay. I can skip this one. This is the update histories. Okay, as Tariq mentioned, we had some discussion about the terminologies We know that there's different terms refer to the similar network construct for the network slice realization. Recent discussion, the agreement is we think a common new term is needed to be defined in the IETF network slice draft, and so that both VTN and the slice aggregate could map to this new term. Next page. So for the next steps, we would like to work with the authors of the IETF network slice draft to produce the new common new term. Then update this document with a new term to make this document ready for adoption. And based on this aligned terminology, we can also collaborate on the protocol extensions and other procedures for the network slice realization. Okay, that's all.
We don't have time for questions. Thank you very much. Please take any comments or questions to the list. Just as a heads up, when we have a countdown, that's the time when you're supposed to be moving on to the next presenter.
Zafar?
With that, Zafar, can you begin?
Zafar? Zafar, we can't hear you.
Hear me now?
Yes, yeah, go ahead.
Sorry about that. So I'm going to present this draft on behalf of my co-author. Next slide, please. For the scope of the draft, it's an informational draft. It lists the essential building block needed for network slicing. It explains how building block interacts seamlessly and independently of each other. The goal for this seamless and independent interaction is to provide scaling and to support incremental deployment. Next slide, please. The draft has been presented. The work started about 3 years ago. The draft has been presented a couple of times to Spring Working Group. We addressed the comment received. We actually make it now target to the Tees Working Group. Next slide, please. So basically, this draft describes the building block to realize a network slice by using constructs at the control plane, information carried in the data plane, and orchestration at the controller. The building blocks are listed here, but the key point is that for a scalable network slicing, these building blocks need to work together seamlessly and independently, and the following slide would explain a bit more. Next slide, please. So let's take a look at what this slide says. This slide lists some attributes of the slice ID to make it work seamlessly with the other building block. The SLID here is identifying a unique IETF network slice. SLID is carried in the packet, so it is stateless. SLID enables slice-specific differential treatment at nodes. So for example, in this figure on the right, we show that a node is serving a green slice with SLID ID 1 and a blue slide with SLID ID 2. Traffic, the green and blue slide slices is segregated by using hierarchical queues. In reality, slide ID is really constructed as like QoS. It is independent of routing and topology, and following slides explain a bit more. Another attribute slice ID needs to have is backward compatibility. It needs to work in a backward compatible manner so that we can have incremental deployments. Next slide, please. So now let's take a look how these building blocks work seamlessly. So let's first take a look at the two building blocks, FlexAlgo and TLFA, in terms of independence. So here, please ignore the green and blue box for now, and let's only focus on FlexAlgo 128 and 129 mentioned in the picture. Let's assume FlexAlgo 129 is for low latency, as shown by the red plane. So if the link between node 5 and 6 fails, we expect the backup to only use low latency backup path. For example, path via node 7 and 8. And indeed, that's an attribute of FlexAlgo. The backup path is optimized for FlexAlgo. We will have to have the same attribute extended to SLID. So now, please focus on the outer box, which is half blue and half green, to show green and blue slices using common network infrastructure. So let's see how FlexAlgo and TILFA and the slit construct works together. For scaling, we cannot replicate FlexAlgo in green and blue slices. It is possible because slice is by definition, the slit is independent of routing and is by design. Similarly, TILFA would work seamlessly for each slice. For example, in this picture, notice the slice ID is stateless. So if you have the same failure between node 5 and 6, and the backup path for the TILFA for FlexAlgo 129 will be confined to the low delay path, for example, nodes 7 and 8, via node 7 and 8. When the packet for these slices will be processed at this low delay path, for example, at the transit node 8, the transit node 8 will apply differential treatment based on the slice ID carried in the packet. So the things work independently and seamlessly as shown for FlexAlgo, TILFA, and slit as an example. Next slide, please.
15 seconds.
So the other slice, other building. So the other aspects of SR policies of FlexAlgo VPN is to also work seamlessly. Next slide, please. So the last two slides just references an ongoing work where the slice ID for IPv6 is carried in a flow label and then slice ID in MPLS is carried in the entropy label. This is the work that we reference or work that we base on or discuss here. On the next step, like Tariq mentioned, there is some ongoing discussion among with Tariq and Jimmy, like the last two presenters, to have there's an ongoing discussion for collaboration and merge. So we will look forward to that discussion. Many thanks.
Thank you, Zafar. We do look forward to the discussion on the list on that document.
Thank you.
Louis? Thank you.
Yes, hello everybody. Can you hear me?
Yeah, we can, Louis.
Perfect, thank you. So I will present this draft. It's entitled IETF Network Slice Use Cases and Attributes for Northbound Interface of the Controller. I will present on behalf of my co-authors. So next page, please. Okay, the motivation of this draft is essentially the following. So the definition of IETF network slice, including the high-level architecture that is documented in the framework or even the data models, all of this is being developed with a clear view yet of what could be the overall needs of the different use cases to be supported in IETF network slices, right? So the rationale that moved us to trying to work on this was the idea that any mechanism that will be used for deploying IETF network slices could be is expected to be used for different ranges of services, right? So at least from the operator perspective, whatever thing that we will deploy, whatever artifact that we will deploy for provisioning and fulfilling the slices will be used for different use cases. So we will go in the direction of unify the provisioning system, so not maintaining separated or specialized provisioning systems per service, but something common, and also considering that even existing services can be expected to be delivered as slices. Once we have all these capabilities available in the network, so move, let's say, the existing services to the notion of slices. So the purpose of the draft is essentially to cover that gap. So analyzing different use cases, identifying SLOs and SLAs, and attributes and methods needed for IETF network slice controller. Next, please. So the updates from last version that was presented in IETF 100.09, essentially we have generated 2 additional versions. We have documented 2 new use cases. This will be detailed in the next slides. There's the one on the radio functional split. And also we have complemented one existing use case. That was the one about 5G services. Here, essentially what we did is to add details in the situation where the IETF network slice customer is the 3GPP management system, the overall 3GPP management system being discussed in SA5 in 3GPP. We have the 2 new co-authors, Jeff and Christophe. And we are working yet in further content. We didn't have time for including it for this version. Essentially, we are working on the consideration of slices being extended to data centers. So what will be the implications of this? Different scenarios where the slice is terminated. And also we are working in a summary table of attributes and functionalities with the idea of providing an aggregate view of what would be those attributes, let's say, the common intersection of attributes and functionalities from all the use cases. Next page, please. So regarding the SD-WAN, the objective would be to support SD-WAN overlays connecting Spark customer sites. Any northbound interface attributes that we have identified so far would be SLOs like bandwidth, service uptime, packet loss, latency, and additional characteristics such as the need of encryption, addressing specific needs of addressing, frame size, and so. Regarding procedures, policy, we have identified the need of having policies per application flow groups, like encryption, internet breakout, etc. And well, the applicability would be essentially to map SD-WAN services into IETF network slices, or even provide IETF network slices as a new form of SD-WAN service, or something like SD-WAN Plus, let's say, simplifying. The reference that we took for collecting all this information was the MEF document, the Metro Ethernet Forum 70 spec. Next page, please. Regarding the radio functional split, the idea would be to accommodate front-haul and mid-haul connectivity by means of slices. Northbound interface attributes considered here would be SLOs like bandwidth, latency, packet loss, etc., as indicated per the nature of the connection. So front-haul and mid-haul introduces specific needs that essentially would map to specific slices in the network. Additional characteristics such as geographical location can have influence because of the limitation in some cases. For instance, in the front haul, we need to accomplish a very strict latency, so this can condition the geographical location of the service. Regarding northbound interface procedures, we do foresee similar slice cycle as the one in 5G services. Probably here, in this case, would be at least how the way in which this is being defined in ORAN, because they are leveraging so much in artificial intelligence and closed loop automation, probably will be more dynamism than in 3GPP, at least by now. The applicability is essentially provisioning of front-haul and mid-haul connectivity, and the reference is the requirements document from ORAN. Next page, please. So as next steps and as a final slide, essentially our direction is to complete the work in progress and correct some typos that are now present in the document. So work in the data center stuff and the summary table, to scan for additional relevant use cases or scenarios, network scenarios, if any. And this from the content perspective. From the interaction with the working group, we would like to collect feedback and comments from the working group, and for sure we will prepare a new version for next IETF meeting, hopefully in Madrid. Regarding, well, also some point that we would like to raise here would be the call for adoption of this document. We feel that this document could be valuable as an input for several other documents in the working group, like the YAM models, or even the network slice controller structure, or the instantiation of network slices in service provider networks. That will be the following presentation, and so on and so far. So essentially, we feel that the need of having a document that specifies what would be required to be satisfied by IETF network slices, and we think that this would be the document for that. And that's all from my side in this presentation. Thank you.
Yeah, Luis, thanks for rolling with the punches. The presentations actually went out of order.
Yeah, no problem.
Because the way it was uploaded, your normal one actually got listed last. We would be interested in objections to adopting that document. It went quickly, so please take their comments to the list, but we really want to hear about objections to adopting that document. In the original agenda that was listed as number 11, it got presented as number 10. And with that, back to you, Luis.
Okay, thank you. So I will present now this other draft, which is entitled Instantiation of IETF Network Slices in Service Providers Networks. So, well, I will do on behalf of my co-authors as well. So next page, please. So the first point here is to clarify what is the intention of the draft and what is not the intention of the draft, just to have clear the scope of this work. So the intention essentially is to leverage on existing IETF capabilities, the IETF machinery, as we told here, to operate IETF network slices and service provided networks. So we are considering here existing young models in either being RFCs or working group documents or even in individual drafts. And what we intend here is to identify how this could be applied for providing network slices as today. So what we could do today with all the capabilities that we have, these artifacts that we already have available, and then identifying gaps, if any, in such a way that well, we could understand if we can satisfy network slice requirements with these artifacts that we have today. It's not the intention of this draft neither defining new young models nor redefining architecture or terminology or adding new requirements. This is totally out of scope. For the work in this document, we have take as inputs different sources. The first, regarding the network slice architecture and the framework, and so we have considered the draft, the framework draft, the merged one that was presented before by Adrian. Regarding the attributes and functionalities, we are considering the draft that I has just presented before. So essentially taking all these two as inputs, let's say, and then in order to evaluate what is available, we have considered the different young models that are already being developed in IETF. Different service models like layer 2 SM or layer 3 SM, different network models as well, L2SM, L2NM, L3NM, traffic engineering models and service mapping drafts in order to play with the traffic engineering capabilities, and also some other drafts like the ones on ACLs and routing policies. And from the architecture perspective, we have also looked into a couple of RFCs, the RFC 8969 about the framework for automating service and network management with Young, and also the ACTN RFC. Next page, please. So regarding the updates from the previous version, we have essentially worked on editorial updates. So the idea has been to make the document much more readable, to align aspects of naming, and also to include the new sections. So essentially polishing the document and trying to make it consistent and readable. We have renamed some sections in such a way we have now a structure with the sections that you can see there: IETF network slice requirements and data models, IETF network slice procedure, network controller operation, operational considerations, and network slice procedure. Well, this is repeated, sorry. We have added as well a new section about the reference architecture and components, where essentially we try to explain how the IETF network slice controller can be implemented in a network operator with different options, and all of them being based on the overall framework that is detailed in the definition document, well, the one resulting from the merge, let's say. Next page, please. So also as an update, we are starting to dig into the different requirements or different attributes and functionalities needed. So in the previous version, we look at the 5G services preliminary we look at them. Now we were looking at the network function virtualization based services as well as the network sharing, trying to pick up and identify what could be the attributes required to be satisfied with the current capabilities that we have developed in IETF. We have created a new section, operational considerations, and we have gone through the different aspects: availability, downlink throughput and uplink throughput, protection scheme, delay, and packet loss rate, trying to understand how all of them could be satisfied with the solutions that we have already defined in IETF, either from the RFC, working document, adopted document, or even individual draft. Next page, please. So next steps. Our idea is to continue to working on different implementation options, trying to understand different capabilities and different possibilities. Also work on security and operational aspects. Our idea would be to collect additional deployment requirements for the gap analysis. So essentially checking the suitability of the models that we already have to satisfy the expected customers of the network slices. Our idea would be also to try to provide from this exercise feedback to the architecture and the solutions works. So the merged document, but also the solution works that we have revisited along today. And also, well, our intention would be to collect feedback and comments from the working group to enhance the document. And then the very big question from our side. So to understand from the working group if this draft is perceived as a useful activity for the working group, and if we should continue working on that and following this direction that we are taking nowadays. And this was the very last slide from my side. So if there is any question, I'm glad to answer.
It would be great to hear from the floor on your question about interest in this document. Denny?
I would be delighted to see more on your document and you just presented. I think it's pretty obvious and coming from an operator and you're touching some very hot topic.
Any other questions? Yeah, personally, I actually completely agree. Okay, I think we have, we're ready for the next.
Hello. Hello, can you hear me?
Please go ahead, thank you.
Okay, thank you. My name is Bo, and I'm here to present this draft on behalf of all the authors. This draft is about IETF network slice service YAM model. Next slide, please. As you can see from the figure that this model is intended to use for the IETF network slice controller northbound interface, which is defined in IETF network slice framework draft. And since last IETF meeting, we have a lot of progress here. We have a new co-author joined, Tariq, join us. And we also receive many comments from mailing list. So we improved the YAM model quite a lot. We received the comments mostly from Matt and also Caccini about the modeling aspects. So next slide, please. Here is the major components of this YAM model. You can see from the picture that we use NS endpoints to represent NSE defining framework, NS framework draft. And we also use NS connection to represent the connections between the NSEs. And each network slice will contains a list of NS endpoints and a list of NS connections. And each network slice can have a global connectivity type and also a global SLE policy, which is derived from the framework, NS framework draft. And we also expand the framework draft's NSE definition with how to treat the traffic, how to clarify the traffic into the network slice as metric NS match criterion. And we also add some attached points to these NSEs. We also add the monitoring parameters to the NS endpoints and NS connections. Next slide, please. we received many comments from Matt, and he has some comments that we think it's necessary to discuss with working group and collect more feedback on this. The comment is about that NSE is a demarcation point of network slice, so it should be add some protocol specific attributes. But given the network slice framework has that the NBI should be technology agnostic, so we propose to use a more general EP peering to it's a list of a protocol to accommodate those requirements. So next slide, please. And also there's another hot one that we received from the MAD, and he said that the network slice should accommodate not just the connectivity requirements, but also some like compute and storage requirements also be needed to considered. And right now we don't touch about the compute and storage, but we touch the model, touch the slice invocation of service functions. We add a policy to as a steering constraints policy to model these requirements. Next slide, please. The authors are also working on the how to resolve the new additions of SLE definition, and we still haven't reached the agreement yet. And this is the first issue about geographic restriction, how to model this, and also the diverse connection. We still not agree on this. Next slide, please. And right now, NS framework give the bandwidth definition that it's must guarantee the bandwidth between two NSE at any time. But we have authors that have also other scenario that we may expand to other like some sharing bandwidth scenario. So we like to hear more from the working group. Right now, the authors are still in the discussion on this, and we haven't agreed on the scenario yet. Next slide, please. And so since this draft has been presented several times, and we received a lot of helpful comments to help to improve this draft. And we think this draft is quite stable now, and there is a lot of interest on this and on this draft, and also this draft is a next step of this of network slice framework draft. So we ask for the working group to consider to adoption this draft. Thanks. That's all. Thank you.
Any questions?
Any?
Yeah, so this is clearly a topic that has received a lot of interest, and the question is going to be for the working group is this a good enough starting point? Again, when we do adoption, it's a starting point, not a final point. I don't think we have time really to ask for questions or objections, but we will definitely take it to the list. Thank you. Next up. Thank you, Bill. Shufeng, go ahead.
Shufeng?
Hi, yes, can you hear?
Yes.
Can.
Go ahead.
Hi, this is Xifeng Liu, presenting a young data model for IETF network slicing on behalf of the authors here. So next slide, please. So in this presentations, I'm trying to describe the data model with some updated clarifications. So this data model is based on other existing IETF young models. So in IETF, we already have many topology models. Many of them already been published as RFCs. Here are some of them. So we have a base topology model, and we have layer 2, layer 3, TE, all the augmentations to the base topology model. And there are some other models augment T topology model. Next slide, please. So here at the right side, we introduce new augmentation. So use this augmentation, we can identify the network slice. Next slide, please. So the way it works is that we use multiple models to bring in all the property attributes related to any technologies. So in this case, if we want to have a network slice with a TE capability, then we will use the network slice model and the TE topology model. So instance of the network slice will have this network type. I see in the diagram, the network type will be both network slice and the TE topology. So with this kind of setup, we can have the attributes for the network slicing and the attributes for the TE. So put them together, we will have multiple inheritance, and we can have the capability to use all the existing IETF models to include whatever needed for our slicing mechanism. So next slide, please. So make it even further. In this case, we can make a network slice with a layer 3 TE, and so it's function aware. So we'll use all 5 models here. We have network slice, we have a layer 3 unicast, we have a TE topology model with the TE capabilities. Under the TE, we'll also have packet switching capability, and also this is so it's function aware. With this, we'll have network type, network slicing, network slice, and then L3 unicast topology, and also we have TE topology. Under TE, we'll also have a packet and the SF. Next slide, please. So here, yeah, this is what we have been updated with some clarifications. So the draft has been presented, I think, a year ago. And since then, we have some progresses on the IETF network slicing definition and the framework document. So with the recent updates, our document, the young model, has been aligned to the latest framework documents. And we also clarified our augmentation relationship. So I also would like to mention that the model has been implemented at least with one implementation. So here on the slide, we have a reference. So now we have the running code. Next slide, please. So we believe that the model is stable enough and ready for the working group adoption, and we still are trying to examine any further enhancements and asking for any comments and suggestions. So that's all I have here. Thank you.
Shufeng, quick question. Do you see this as a NBI model, or is it a model that can be used after a service request comes in?
I think Louis's document we heard earlier before have a description about how do we use this model and other models. So if you look at the ACTN document, this model is pretty much equivalent to the type 2 service. And the other one, so it's a type 1. So the model usage is also described in the ACTN Yang drafts. So they have all the different scenarios. We can use different setups, either use at the in the middle of the networking stack or at the very top of that. It all depends on the use cases.
Okay. Yeah, I guess you're saying if the consumer or the customer has some notion of what the topology is that the service provider has, then he should be able to use this model.
That's right.
That probably needs some discussion, but yeah, I think I understand what you're trying to say. But that is not articulated well enough in this document, at least the scope. If you can clarify that, that would be useful.
Yeah, we can do that. But there are also some other document. There are several documents trying to do this for the same purpose. We have ACTN model description document. We also have Louis's information document.
Okay. Any other questions for Shufeng? Okay, I think we can move to the next presentation.
All right, thank you.
Thanks.
Hello, can you hear me? Yes.
Yeah, go ahead.
This is Bo again, and I'm here to present the VT network Yang model. Next slide, please. As presented before about the slice aggregate and VPN, the enhanced VPN actually defined this term of virtual transport network. It contains the parts of the physical network resource and with customized network topology, and including a group of nodes and links. Here on the left-hand figure shows what will the VTN network VTN looks like. From the physical network, there will be partition. This is an example that here that the two VTN network partition the physical network into two, and each with different network nodes and links. And this Yang model is it's used between network controller and network slice controller, and try to manage and monitor the resources allocated to VTN, like which nodes belongs to VTN and which link belong to VTN, and each link what's the bandwidth reserved for this VTN. And the relationship with network slice is when realizing network slice through enhanced VPN. A VPN can be used to deliver a set of VPN services, and each VPN service may represent a network slice service. And this VPN network model can be used to provision the resolved resources for the services. And the resource the intention of this resource reservation is to provide network characteristic required for the service, like some of the link is low latencies, and there are more of links for the backup resources. Next slide, please. And here is a modeling approach of this VTN network model. And this model is designed to as a augmentation to the network topology Young model. We think that the network topology model can have the information of the physical network, and based on this physical network topology, will like partition the physical network resources into different virtual transport network, and each transport network will contain a list of nodes and list of links, and we also each VTN network has its global attributes, including what's a bandwidth reservation for this VTN, and what's a control plane for this VTN, and also the data plane, and how to steering traffic into this VTN. And we also augmenting the link of augmenting the list of IETF network link with VTN attributes, including like how many resources reserved for this link, and what's a link type could be used for this link, and also like how many like the usage of this bandwidth. Next slide, please. We also think the VTN can also be used for helpful for the multi-domain use cases. And there is a draft about end-to-end IETF network slicing that describe a more detail of how to use this VTN in a multi-domain scenario. And here I just gave just a reference here that like a different VTN from different domain can be stitched together to form integrated VTN global VTN network that a multi-domain controller can use it as an underlay of a VPN services. Next slide, please. And this is a very initial draft. This is a zero draft, and we like to solicit more comments and reviews from working group to see whether it's we think it's helpful to support the slice service in a more scalable way. So that's all for this model. Thanks.
Any questions?
Yeah, thank you for actually leaving time for questions.
Thank you.
Italo, you're next.
Okay, this draft, I'm presenting this an update on the draft on the MPLS-T topology. Next slide, please. Okay, what is the issue of this draft? Okay, this draft has been a replacement of the initial proposal for an MPLS-TP topology Young model. It was presenting in IETF 104, and the feedback was that since TP is a profile of traffic engineer of MPLS-T, not in something, we agreed that the best thing would have been to integrate the MPLS-TP topology together with MPLS-T. So we had some follow-up discussion, And this draft has been generated to cover the MPLS-T topology, including MPLS-TP, and the plan is to update the MPLS-TE tunnel for the MPLS-TP tunnel setup. And the output of that discussion has been shared on the TISM and MPLS working group mailing list when we publish the first version of this draft. Next slide. Okay, the approach of this model is that the MPLS-T topology will be an augmentation of the T topology packet in parallel with the Ethernet T topology. And so the idea is that whatever is common for any packet technology will go into into the T topology packet. Whatever is specific for MPLS-T will go into MPLS-T topology. Next. And what we have done after the last IETF, we have basically, following that approach, we have moved some definitions which were common and applicable to MPLS-T, but also to Ethernet, from the MPLS-T types to the T packet types, in particular the identities for the bandwidth profile and the groupings that are used for packet link and path bandwidth. And we have some discussion about how to represent the bandwidth, and we define a new type for the bandwidth that can be ascribed in a scientific notation to allow encoding from kilobit to terabit type of bandwidths. And we moved, as a consequence, all the augmentations of the T bandwidth, which follow the A795 guidelines, which are applicable to packet technologies, from the MPLS-T topology to the packet topology, which was presented by Shufeng. And we are continue discussing these issues with the other traffic T's experts, and we have using the same GitHub, and we have written this new version in Cramdown to easy to track revisions. Next. So the open issues is about whether we need how much information we want to give to the controller in terms of label augmentation. And when we look at the initial motivation of the draft, which was MPLS-TP, we found that label allocation are usually done by the network element, and the tunnels are single domain. So there is the label allocation is not something that needs to be exposed at a northbound interface of a controller for an MPLS-TP network. So we don't see the need to provide too much information about the label range available on a link. We would like to get confirmation from the more broader applicability of MPLS-T. And we also think that the draft is ready for working group adoption. And as I said, is just as a first starting point to progress the current work. I think that's the last slide. Thank you.
Any questions?
Be interesting to see if there's interest in this work from the working group. I actually didn't track all your references, and I'd be interested in seeing those again, but I can do that offline. But just as if anyone has any comments on general interest in this topic. Does anyone want to express that anyone think we should not be working on this? I think at this point, Italo, we should discuss it more on the list, but you know, maybe it's because we're running the end of the day for many people. I know this is we're in very many different time zones here, but definitely less energy right now. I don't think we should take that as disinterest, though, because no one came to the mic. All right, thank you.
Okay, so we will ping the list to have to gather interest on this document. Okay, thank you. Okay, the next is about the profiles for the T topology model. This is the update. This draft has been already quickly presented in the previous IETF. Next slide, please. Next slide, please.
1 second. Yeah, one
okay,
second.
okay.
I'm having issues with that one. Yeah, go ahead.
Okay, what was the motivation? Is recap a bit of what was the motivation. We have seen, I've seen multiple discussions, and there are many discussions in various IETF working groups where we have non-T networks, which requires some YAM model that provides attributes which are already defined by the T topology, but not all the T topology model, just a subset of them. And the initial reaction for many people is that the T topology model looks very complex because it is extensive since it supports many features. And some of the features are applicable only to traffic engineering networks, but other features are applicable also to T and non-T networks. And what is missing is that most of those features and attributes has been defined to be optional, such that the T topology implementation can be tailored to a specific need. So the draft has been driven, the motivation of this draft is to clarify to a broader audience whether that the subset of the T topology can be reused in a specific scenario, including also non-traffic engineering use cases. Next slide, please. Okay, some examples that are provided by the draft are unit topology discovery, the management of the state of administrative and operational state for links and nodes, the geolocation for the interfaces, the description between a relationship between overlay and underlay topology, or when you want to describe some nodes with switching limitation, even if they are non-T. For example, you abstract the whole network and some endpoints are not reachable. Next slide. And this draft also gives some examples on how technology-specific augmentation can be defined, and there are multiple options. One option, which is basically a chain of single inheritance, is to augment the T topology. And the other option will be to augment the network topology and to have the T topology in a multi-inheritance to get all the generic attributes which are defined by the topology, or a subset of them, depending on the profile being used. Next slide. And so what has been changed after last IETF? We have added a new there were some questions about whether the multi-inheritance description we needed to provide more text, and we add a new section 3.1 because the RFC 8345 defines the network topology, network types as a presence container, and inherently allows the multi-inheritance. But this capability is not explicitly described, and therefore there was a comment, and the discussion we had was that this document could be a good common reference for other drafts that are using common multi-inheritance to describe how the multi-inheritance works, and we added this new section. We have started to add a new section 4 about an issue that was raised about how can a server knows what is the profile implemented by the client can know what is the profile implemented by the server, which is important for when the topology is read-write. And we have investigated with NetMod working group whether this is a generic problem. The feedback was that this issue is a young specific model issue, and we need to find a way to report this information. And we also continue discussing this document under the T GitHub, and we have rewritten the document in Cramdown. Next slide. So what are the next steps is maybe we need to advertise this draft to other working groups, in particular Pseria and CCAMP. We got a comment from Daniele, which we forgot to implement in this version, to clarify the title that the model is applicable also to non-T use case, the profile, and we will appreciate more review and feedbacks, and also on addressing the open issues and any other comments. And we think we have some discussion, and we think this document is available, and we will think will be good to progress this as an information RFC, and we think it could be a good step for a working group adoption as well.
Okay. Any questions for Italo? We have less than 2 minutes before we wrap up.
think we have the same questions we had on the previous document. Is there interest in the working group on this?
Yeah.
Okay. It looked, yeah, do take it to the list. I think.
Okay. Yep.
Just like the last presentation, I guess this is the end of.
Something to you. Scott, we still have 30 seconds. If you want to take your, we have time for your question.
I just wanted to point out I did put something in the chat. I think this is good stuff. So we need a home button or something, but I think this is good. But there are some things I would like to see clarified. That's all. Thanks.
That'd be great to send it to the list. Appreciate the feedback, particularly at the end of this IETF day.
Okay. I think with that, we can close the session. Thanks everyone for joining. We will hopefully see you again in an interim. We will share details as and when that gets confirmed. If not, yeah, see you at the next IETF. Thanks everyone.
Thank you.
Thank you.
Yeah, and thanks to everyone who helped take the notes. Thanks.